Now, I have just an hour ago sent you the homework assignments. So the rules are, there is a list listed there of A problems that you have to solve by the specified date. We have, let's call it a point system. So for every assignment, you get a certain amount of points. You also get points by attending lectures, not attending lectures, but I will give you small questions during lectures, and you will have to submit them, answers to those questions. So, let me, I will try to write it down. So, 3 points for lectures. Not just attendance, not attendance itself, but simple problems I will give you during the lectures. Stuff like, did you listen? 3 points seminars. Those would be determined by your professor on the seminars, maybe it would be me, and also simple stuff like attendance and paying attention and participating. Then we have 3 homework assignments. For each assignment, you have 2 points for the homework plus 6 points for the test. I don't like this program. It's lagging. So after each assignment, roughly at the date of, roughly at the due date of the assignment, you will be given a test on the seminars, like several problems. You will solve them, submit, and you get maximum 6 points for this test. So we have 3 assignments. 3 assignments times 8 points. You have 24 points for assignments, plus 6 points for participation in our classes. So a total why you're not working? What? What's going on? It's lagging. It's lagging over here also. No? Do you work? Ah. Do you work? Okay, I see. It's just назад действие. Это хорошо. Я уже кучу всяких действий сделал. Спасибо. Это полезно, что вы мне напоминаете, но... Окей. Yeah, thank you. So, total 30 points before the exam. You can have at most 30 points before the exam. And you will have 70 more points during the exam. So your answer during the exam is out of 70 points. It's actually a bit complicated-ish. So we have 10-point grade system, so out of 10. And your grade after for your answer on the exam will be multiplied, please come in, by 7, and you will have 70 points for exam. So a total of 100 points. And out of those 100 points, you will get your final mark. Okay. Basically, the important part the most important part is the exam. There at the exam, you will have the most important part is theoretical knowledge that we will discuss during our lectures. But you will also have to be able to solve the kinds of problems in the problems like in the assignment. During the classes, the most important part is doing the homework and successfully writing the tests. So this is the grading system. Okay, today we are moving on. We continue our discussion. Today's topic is trigonometry. Once again, I expect you to know all of this already. So this is not some new information. This is a list of things that you should know by now. If you do not know it, so if anything from what I'm discussing today, not explaining, is not clear, then this is the time to ask questions, okay? Once again, I expect you to know this already. I'm spending this time to be sure, okay? So, trigonometry. We have a unit circle. This is x, this is y. We can put some angle, I will call it alpha, this angle alpha. We measure our angles in radians in trigonometry. You can also, in other fields, use maybe degrees or something else, but in mathematics, specifically in calculus, it's much more convenient to use radians. So the whole circle is 2 pi radians. A quarter of circle is pi by 2. This half a circle is pi. This is 3 pi by 2. And this is 0, which is also 2 pi. We measure angles that way, counterclockwise. I expect you to know how to put any angle on the circle. For example, if I ask you to put minus 1000 on this circle. I'm not asking you to do the calculations. Do you know in general how to do this? Okay, is it clear for you? Minus 1000. Can you find it here, given the given time? Okay, is it clear or not? Either say yes or no. Okay, okay. So then we find this point of intersection with our circle. It always exists. And the coordinates of this point are, let's call it x, y. And we define sine alpha as y, cosine alpha as x, tangent as y divided by x. Note here that firstly we have this notation for tangent. I know that in some countries they use different notation. In Russian literature we use this TG, tangent. Also note that if x is 0, then this expression is not defined and tangent is also not defined. This happens at those 2 points, this point and this point. Cotangent x divided by y. The same remarks. CTG and not defined at some points. Next, there is like a table of values that those functions attain at specific points. So we have functions sine, cosine, tangent, cotangent. At points 0, pi by 6, pi by 4, pi by 3, pi by 2, pi 3, pi by 2, 2 pi. And I expect you to learn by heart, to know by heart, maybe you should have learned in school, all of the values of those 4 functions at those points. So sine 0 is 0, cosine is 1, tangent is 0, cotangent. Once again? It's not defined. Cotangent not defined, yes. Pi by 6, 1/2, square root of 3 by 2, and so on, and so on. All of those points, okay? If you do not know them by heart, you can easily find this table. It's like everywhere in any book for trigonometry. Do you, is there anybody who is not ready right now to fill this table, who doesn't know this by heart right now? Okay, everybody knows this. Okay, so the next point, the next part is identities. First of all, we have the main identity, that is sine squared plus cosine squared equals 1. This is, of course, just follows from that point that I drew earlier. laying on a unit circle. So this is the distance sine squared plus cosine squared. That would be x squared plus y squared equals 1. So it just follows immediately from the definition. Now, those formulas, cosine alpha plus or minus beta is cosine alpha cosine beta minus plus sine alpha sine beta sine alpha plus or minus beta is those formulas for sine or cosine of like sum. From here, of course, we have formula for tangent alpha plus or minus beta, which is tangent alpha plus minus tangent beta 1 minus plus which is obtained by dividing those previous two one by another. And a similar formula for cotangent, which I'm not going to write. We have those formulas, those kinds of formulas. Sine pi by 2 minus alpha equals cosine alpha, and all other those kinds of formulas. I actually don't know how to call them in English. Формулы приведения. Кто-нибудь знает, как по-английски? I don't know. Well, basically those kinds of formulas. So sine of pi by 2 plus minus cosine of pi plus minus sine 3 pi by 2 plus or minus, stuff like that. So every kind of function, including tangent and cotangent, of those kinds of expressions. Say tangent of pi minus alpha, those kinds of formulas. There are like, there is a structure in those formulas, but I don't think I need to explain it. I think you should know it from the school. Formulas for sine of 2 alpha, which is 2 sine alpha cosine alpha cosine of 2 alpha, which is cosine squared minus sine squared, which is also 2 cosine squared minus 1, which is also 1 minus 2 sine squared. Similar formula for tangent to alpha and cotangent to alpha. Those formulas, I remind you, could be easily obtained from here by writing, say, cosine alpha plus alpha. Also, by rearranging, say, these formulas, we can obtain sine of alpha by half, which is 1 minus cosine alpha by 2, and also cosine alpha by half, which is 1 plus cosine by 2, stuff like that. Those formulas. Let's move on. We also have so-called universal substitution. So it's usually, not usually, it's sometimes convenient to make this substitution. New variable is tangent alpha by 2. Usually this leads to very big calculations, but it works basically every time, this substitution. So we have sine alpha is 2, I will call it t, I'm using this substitution, over 1 plus t squared. Cosine is 1 minus t squared over 1 plus t squared. Tangent is 2t over 1 minus t squared. I think this is correct. We of course also have formulas for sine, cosine of 3 alpha, which is 3 sine alpha minus 4 sine cubed. Is 4 cosine cubed minus 3 cosine alpha. And similar formulas for tangent and alpha and cotangent of 3 alpha. What else do we have? Yes, we have one more group of formulas of identities. Formulas like transforming a product of two functions into sum or the other way around. So sine alpha cosine beta is 1/2 sine alpha beta. Similar formula for cosine times cosine and sine times sine. And from here we can obtain formulas for sine alpha plus or minus sine beta, which is sinus proxima and similar formulas for cosine alpha plus cosine beta and cosine alpha minus cosine beta. Okay, those formulas. Those are roughly a list of identities that our Russian students learn in school. Anything new here for you? Do you know this all already? So, if any of this is new to you, please Google a list of a table of trigonometric identities and learn those by heart. We will use them from time to time. Okay? Okay, now let's see how we can a couple of examples. Example 1. How much time do we have? Yeah, I'm checking the time. Okay, example 1. Suppose we know that sine alpha be equal 12 by 13, and we want to find cosine alpha. A very easy problem. We just write down our main identity, sine squared plus cosine squared equals 1. From here we can express cosine. I'll write it like this. Cosine squared equals 1 minus sine squared. We can put here our value for sine, 1 minus 12 squared by 13 squared, 144 over 169, which is 25 over 169, which is 5 by 13 squared. And from here we can say that cosine is either positive or negative 5 by 13. Note that we have two solutions. Okay, new problem. Maybe I'll put it here. Example 2. I want to find sine of 75 degrees. Any ideas how to do this?
45 plus 30.
Yes, of course. So sine 45 plus 30. It's easier for me to do all calculations in radians, so I will write it down as sine of pi by 4 plus pi by 6, and we can use our formulas that I wrote before. This would be sine pi by 4 cosine pi by 6 sine pi by 6 cosine pi by 4. And the answer would be 1 1 over root 2 square root of 2 over 2 plus 1 over root 2 1 half, which we can combine. Should we? We could. That would be square root of 6 plus square root of 2 by 4, I think. Something like this. Is this completely clear? It's very important that this is completely clear for you, not mostly clear, but completely clear. Okay, moving on. Example 3. I want to calculate cosine of 1 degree plus cosine of 2 degrees plus and so on plus cosine 179 degrees. We of course can't calculate easily any of those numbers, well, unless we already know them. So for example, calculating cosine of 1 degree is a difficult problem. So what do we do?
We can take the first one and the last one and use a formula for the sum of the cosines.
Yes. Which formula? Cosine plus cosine.
Yes.
We could, but there is even better way. So let's look at those numbers. So cosine of 1 degree plus cosine of 179 degrees, which is cosine of 1 degree plus cosine of 180 minus 1 degrees. What is cosine 180 minus 1? Negative cosine of 1 degree. Yeah? So this would be cosine of 1 degree minus cosine of 1 degree, which is just 0. And this also happens like 90 times here, not 90, 88-ish times here, so we have a sum of zeros, and the answer is 0. Much easier than any other way, I think. Any problems here, any questions? Okay, let's take a break. Feel free to ask me questions. Now, we have already defined trigonometric functions, but now let's explore them as functions. So, functions. First function. F of x equals sine x. This function is defined everywhere. For any real number we can calculate its sign. So its domain d of sine is the whole set of real numbers. It attains values from -1 to +1. So its codomain, I will call it E of sine is a closed interval from -1 to +1, this function is periodic and the smallest positive period is 2 pi. Sine of x plus 2 pi equals sine of x. What else do I need? Yes. It is also an odd function. Sine is an odd function. So sine of minus x equals minus sine x. And the graph of sine looks something like this. Zero, pi by 2, pi, looks like that. Okay, anything here is new to you? Maybe some terminology is new. Maybe some symbols I write are unfamiliar. Maybe this symbol is unfamiliar. This symbol is a set of all real numbers. We will discuss it thoroughly later, but for now it's just all real numbers. Okay, so this was sine. A similar explanation we can write for cosine. I'm not going to spend time on this, but this is a similar idea. But I will spend time on tangent. Third case, f of x is tangent x. So, what is the domain d of tangent? Let's ask maybe some of you. Raise your hands who are ready to do this exploration of the function tangent right now. 3-ish people. Should I, for everybody else, should I do this more extensively? Should I explain more? Guys, talk to me. I'm spending time on school topics not because I just like it. I want you to be absolutely fluent in this part of the mathematics. Is it so right now? Because I don't think so.
Maybe you can explain.
Okay. What's your name?
Jeremiah.
Jeremiah. Okay, Jeremiah. What is the domain of a function?
Real numbers.
No. What is the domain of any function? For sine, the domain is all real numbers, but what does the word domain mean? What does it mean, a domain of a function? Anybody?
The domain is like values of x for which function exists.
Yes, those are values where the function is defined. So, Jeremiah, where does this function is this function defined? For what angles we can calculate the tangent of that angle? Raise your hands who knows the answer. Okay, let me explain. Once again, we return to our definition. A unit circle, this picture, and we discussed that tangent is, what was it, y divided by x, where y and x are those coordinates, x, y. So, Jeremiah, tell me, could it happen that we cannot calculate this value? Why not? Can we calculate this value for any angle?
I think yes.
No, you're wrong. I did mention this today. Marta, can you tell me where is this function defined? What are the angles such that we can calculate this expression?
Maybe from the positive side.
Once again?
From the positive side.
What's the positive side?
Top of the graph.
Top of the graph. This is not a graph of a function. And no, the answer, no, this is wrong. So, look, we have to divide y by x. What could happen? What's the worst that could happen here? Why can we not divide y by x?
If x is 0?
If x is 0, of course. This is the only problem that could happen. Can you see? Okay, Jeremiah, tell me, what are the points where the x is 0?
On the y-axis.
Once again?
The y-axis.
Yes, y-axis. And since we live on the circle, we have only 2 points, this point and that point, where the x is 0, okay? So, this point is pi by 2, this point is 3 pi by 2. Yes, Arsha, probably Arsha, yes, Arsha is correct. Lan was not correct, but he was correct-ish in a different sense. We'll return to that later. So, those points, like pi by 2 and 3 pi by 2, are the points where our function is not defined, okay? Jeremiah, tell me, how many points in total we have where the function is not defined? No, not 2. How many in total? Infinitely many. Do you understand, guys, why we have infinitely many points where the function is not defined? Okay, Jeremiah, tell me, where is the point 5 pi divided by 2? So 2.5 pi. Where is this point? Or on the unit circle? Can you tell me?
No.
No. Okay.
P over 2.
Yes, this is also this point. This point. 5 pi by 2 is also this point. Because, look, 5 pi by 2 is 2 pi plus pi by 2. If we start at here, we turn 2 pi radians, we make a whole circle, a whole rotation. And then we also need to move pi by 2. And we reach this point once again. So, if we start at pi by 2 and add an even number of pi's, so to say, so 2 pi times a whole number, we will also land on this point. And the same happens here, of course. So, in total, we have points such as pi by 2, or also, if we start at pi by 2 and we go just any number of pi's, so if we move just 1 pi, starting here, we will land in this point. 1 pi is just the opposite point on of the circle. So, starting here, plus pi, we'll land here. If we add once again pi, we'll land once again here, and so on. So, in total, all of the points where the function is not defined could be expressed as pi by 2 plus pi times k, where k is an integer number. This denotes a set of integer numbers. We will discuss it later more thoroughly. Okay? So, from here we have the domain of the function. Okay, can you tell me now, what is the domain of tangent? Once again, the domain of the function are the points where the function is defined. We discussed where the function is not defined, at those points. Here, tangent is not defined. So, the domain are all other points. We will denote it like this. So, I'm starting with the set of all real numbers, R, and then I'm excluding some elements of this set. We will denote it like that. R excluding those numbers. Pi by 2 plus pi k, where k is an integer number. Okay? Very well. Now, who can tell me about the codomain of my function? The person on the last table, what's your name? T. T? Okay. Can you tell me what is a codomain? No. No. Guys, once again, I repeat. Over here, I told you something about sign. And you all acted as if you understand it all. So, in those kinds of situations, you should, this is my explicit order to you. If you don't know what is a domain, raise your hand and ask a question. I would answer, I would explain, and so on. Because those of you who will fail to grasp everything that, not even everything, most of the things that we are discussing, will fail this course. And this is school topics. This is stuff you should already know. We will move to a harder topics. I promise that will be proper calculus. If you don't understand anything, ask away immediately. Otherwise, you will lose the thread of the lecture and you will not be able to recover. Do not make this mistake. Okay? Okay, the other person on the last table, what's your name? Yeah, once again? Queen? Like a female kind of king? That queen?
Q-I-N-I.
How do you spell it? Q-U-Y? Like that. Okay, almost. Okay. Queen. Queen, correct? Okay. Queen. Queen, could you tell me what is a codomain? Codomain, what's that? Once again? No, I'm asking you about the word codomain. What does it mean? A codomain of a function. I'm not asking you about specifically this function. Okay. Who can explain me?
A codomain is the value a function can give. It is also called range.
Yes. What are the values that the function can attain at least somewhere? Okay? And what's the codomain of tangent?
Minus infinity to infinity.
Yes, this the whole real line. So this is a whole set of real numbers. Okay, moving on. What's the period of a tangent? The period is pi. Yes. Tangent of x plus pi equals tangent pi. It could easily be obtained from the definition. Okay. T. Here we said sine is an odd function. Do you know what is an odd and what is an even function?
Professor, is f minus p equal to f is.
Okay, I think this is correct. So an odd function is such a function that f of negative x equals minus, so negative f of x, and an even function is f of negative x equals positive f of x. Okay, T, could you tell me if this function is odd or even or maybe neither of those? The function tangent.
The question is even function?
Yeah. Tangent x, of course, thank you. Yes, this is an odd function. It is actually an odd function. Tangent is an odd function. Once again, tangent of minus x equals minus tangent x. Yes, codomain and range are the same thing, yes. To be clear, range sometimes refers to like from minimum to maximum, and one can like read this word as if to mean that the function attains all of the values in between minimum and maximum. It is not always the case. Maybe the function attains some values, maybe for example attains a value of 1 and attains maybe a value of 0 and doesn't attain any values in between. This could happen. So in this case, the codomain and the range are the same and they consist of 2 points, 0 and 1. So yes, this is the same, but do not like read it incorrectly. Okay, it is also the domain of inverse function. Onur Dossi says, codomain is also the domain of inverse function. This is wrong. It is kind of correct, but this is wrong. If you give me those kinds of answers on the exam, you will fail this course. What's wrong with this statement? Once again, Onur Dossi says, codomain is the domain of the inverse function. Why is this wrong? Could you explain me? Yes. The inverse function is not always exist. For example, we have maybe this function sine. This is the graph of this function. The graph of inverse function, it is like flipped like that. So x goes to y, the x's flip into each other. And if we draw such a picture, this is a flipped graph of sine. We can see that this is not a graph of a function. Guys, raise your hands, those of you who could explain why this is not a graph of a function. Oh, I see. Okay. So, look, a function, yes, Lan, you are correct. Yes, Onur, you are correct. Onur says this doesn't pass vertical line test, which means if we draw any vertical line, say this line, then it should intersect with our graph at most at one point. Maybe it doesn't intersect. In such case, the function just not defined at this point. But if it does intersect, it should be only one intersection. So the function for any value of x attains exactly one value of y. Here, this is not the case. We can have this point and this point. So this is not a function because for the same value of x, this value of x, we have two different values of y. So this is not a function. Guys, I urge you to be to engage more with me, ask me questions if you don't understand anything. If you don't understand this by the exam, you will probably fail the exam. These kinds of things. We will get to harder topics later. Okay? Okay, so once again, yes, if the inverse function exists, then yes, codomain is the domain of the inverse function. But the inverse function is not always there, doesn't always exist. For example, for all of those trigonometric functions, the inverse function doesn't exist, at least on the whole line. This was for sine, and the same story for other things. So tangent is an odd function, okay, and let's draw the graph of the tangent. It looks like that. From minus pi by 2 to pi by 2, it looks like that. It is not defined at those points, and it tends to infinity. What is the limit of a function we will discuss thoroughly much later. I think you should already have the idea, the rough idea of a limit. So this goes to infinity as x goes to pi by 2. And then this picture is copied infinitely many times because the function is periodic. So we can go like that, and of course over here. Okay. Questions? Okay, what else do we have? And we didn't even reach the equations. Okay, we'll do it quickly. So let's move on here. Now let's discuss the equations. Suppose I want to solve, I will start with cosine, yes, cosine equations. I want to solve an equation, cosine x equals a. This is the idea about the solution. Unit circle. Now, I remind you that cosine is the x coordinate over here. So if cosine equals a, then this means that x equals, not this x, maybe cosine alpha, I will call it cosine alpha. Then x equals a. X equals a is a vertical straight line. Yeah? So maybe over here is point A, and we have this vertical straight line, vertical-ish. This line on my picture intersects with our circle at 2 points, this intersection and this intersection. Could it intersect our circle at maybe only 1 point? Could it happen?
Yes.
Okay, how could it happen?
Right position, right.
Yes, if we move it, if a equals 1, for example, then it will be a tangent line at this point, and it will have only one intersection. And the same happens over here if a equals -1. Could it intersect our circle at more than 2 points?
No.
Of course not. Could it not intersect our circle? Yes, of course. If a is either greater than 1 or less than -1, it doesn't intersect. So, if a is between -1 and 1, we have some intersections. And this equation have some solutions. Very well. Now, like this solution, this top one, say top one, is called arc cosine A. So this point is called arc cosine A. This is the graph of cosine. Starting from 0 and going to pi. So this is the graph of cosine. On the interval from 0 to pi, cosine is an monotonically decreasing function. Later we will discuss that from here it follows that this function has an inverse function on this interval, and that inverse function is called arc cosine. This is the graph of arc cosine. So this is cosine x, and this is the graph of arc cosine. Like that, yes. Like that. This is pi, this is +1, this is -1, this is 0, this is pi by 2. So this point is arc cosine A. This is one of the solutions of our equation. This, of course, is minus the same value. So the solutions here are alpha equals plus or minus arc cosine A. And of course, since function cosine is periodic, with 2 pi as a period, we have plus 2 pi over here, plus 2 pi times integer number of times, plus 2 pi n, where n is an integer number. Okay, you should, yes?
You should write something about A.
Yes, this happens for, yes, thank you. This happens for A is from -1 to +1. Okay, you should have learned this at school. Anything new for you? Our time is sadly out. but we will maybe continue this discussion on the seminars, maybe on the next lecture. Any questions? Okay, thank you.